Part of the shift in how attackers think of networks and enterprises is basically, where do I get my money from? And there is a seismic shift that came from attackers no longer going after data as much as after the operations of a business. So ransomware is not only on the rise, it's on an exponential curve of a rise, and connected devices play a part in multiple ways.
In an average environment that we are going to, 80 to 90% of the devices there are unmanaged. And basically this is just growing and growing and creating a huge gap around visibility and control of those assets. And this is being leveraged by attackers more and more.
When we started Armis, it was a shock to us that enterprises just have no idea what they have on their network or in their environment. We've seen even situations where devices as innocent as a boardroom control tablet are sending out large amounts of data, which turned out to be video and audio from the boardroom to some unknown internet location.
Armis was basically built to be the best in the world in knowing devices, from the basics of understanding what a device is down to the exact make, model, OS, which is so crucial during an investigation and provides us a lot of data that allows us to learn patterns of what's good, what's bad, and how an attack would look like on a variety of different types of devices. It allows us to detect this fast and also to stop it in real time.
One solution that can provide a complete converged view of everything and a complete security for the entire environment is the only way to go, and that's really what Armis is building.
Good afternoon, my name is Keith Walsh, and I am the Director of OT Strategy and Operations with Armis. And you just met Nadir and Yevgeny, and they are our founders at Armis. And 6 years ago, they started on this journey to create this cyber platform that is agnostic to devices, agnostic to technologies, agnostic to protocols. And where they have brought it in the last 6 years is really the industry's leading cyber asset security platform, because it does just what you heard, which is, in fact, the discovery and the tracking of every single device, wire to wireless, as it crosses any enterprise, OT, IT, IoT. And that brings us to today's presentation. So today's presentation is about critical infrastructure. And as we flip through this, we're going to start with our target of, in this particular case, it happens to be a U.S. Marine port here in Florida. And it's interesting because as we're not all here employed by Marine port operators, we certainly are involved in critical infrastructure, whether it be utilities, gas, water, wastewater, whether it be pipeline, critical manufacturing. So as we walk through this presentation, it's incredibly important to really kind of devoid ourselves from the fact that this is a U.S. Marine port and really understand that this really could be any kind of critical infrastructure whatsoever. This particular port, as you see here, has got 33 million tons of cargo, billions and billions of dollars of economic impact, and thank you. And billions of dollars of economic impact. So it really gives us an idea of the types of downsides when our critical infrastructure gets hit, of what is at stake. So this occurred October 13th, October 14th of 2021. And what we're going to do is we're going to run through a sequence of events. We're going to run through some logs. We're going to run through some alerts and really get into triaging and understanding the forensics of what an attack looks like. And it's a very simplistic attack, which is unfortunately all that alarming. So I'm going to flip through and I'm going to offer some color on what happened. And there's also going to be some audience participation. So please don't be shy. So on October 13th, there was a drive-by on a U.S. Marine port. And what it was reconnaissance. Our adversary in this particular instance is a machine. It's a machine name. The machine name is XPS Black. And what XPS Black does is they simply do a drive-by past the marine port. And what they're looking for is they're looking for access into the infrastructure, right? So since it's obviously not an insider attack, so they're not going to be plugging into an industrial switch, an L2 switch, an L3 switch trying to gain access. This is an external attack, so naturally, if local individual, they do a drive-by. And that's exactly what happened, as you see here on October 13th. So XPS Black then revisits the port, and they revisit it the next morning, and they run a DAuth attack. Now, if you're not quite sure what a DAuth attack is, you could just simply Google DAuth attack. And it's a very common attack, hotels, public places, airports, those types of things. It's a brute force, man-in-the-middle type of attack. And what XPS Black does is they connect to the SSID of Port Authority, and they grab an IP address of .116, as you see here. That happens at 6:51 on the morning of the 14th. So what does XPS Black do? So XPS Black then begins to launch an unauthorized piece of software called Nmap, right? We probably all know what Nmap is. It's a ping sweep type of scanning platform software that reaches out to infrastructure, devices, and it looks to see which types of ports are open. And that's exactly what XPS Black does here. They begin a network scan, and they're scanning for, among other things, port 502, port 2222, port 44818, and then along the way, as you'll see, they cross Raspberry Pis, they cross over on cameras, on all the other infrastructure, the IoT devices, the sensors, the badge readers, the card swipes throughout the infrastructure. But they do, in fact, find a device. Now, audience participation, anybody? 502? Know what protocol that runs? Sorry? It is Modbus. Yeah. So this is Modbus. So, you know, if we rewind the clock a couple months, remember Pipe Dream, right? Same thing, Modbus, port 502. So there's actually an interesting parallel between what we're seeing here and what was presented in the Pipe Dream information that was put out by CISA. But so what has happened at this point, in a couple of moments in, XPS Black does a port scan, right? They've gained access into the wireless infrastructure, and then they begin a port scan of the network. So they then, a couple of moments later, they've got a device that reports back. Internet ports, port 23, and in fact, port 502. So device responds back port 502. They're like, oh, Modbus device. This is now interesting. So at this point, XPS Black, unfortunately, then connects to a device that is called Crane PLC. And it's at this point where we might actually get the very first understanding of who our adversary might be, right? If I've got an adversary who's got industrial protocol software applications on his machine, obviously has the ability to do port scans, network scans, forensics on the network, and then they connect to something on port 502, we kind of start understanding that we're not dealing with necessarily somebody in their basement, low-funded, low-skill level type of individual. We're dealing with somebody that has a modicum of training, understanding of industrial control networks, understanding of what these devices are, and clearly understanding of industrial protocols, because they in fact settle in on Crane PLC. Now, interestingly enough, you'll notice off to the right in those statements, these activities are logged, right? So it was actually observed that this activity was happening. So we've got all the information we need here to do forensics. So a couple of moments later, XPS Black sends multiple coil writes. If you know what ladder diagrams and rung edits are in the SIP world, same thing in the Modbus world, right? Coil writes are modifications, in this case, to the Crane PLC. Unfortunately, in this case, the Crane PLC had hoisted a 40-foot container about 50 feet in the air. So a moment or two later, Crane PLC released the 40-foot shipping container into the port. XPS Black then disconnects from the wireless infrastructure, and after about an hour or so of probably looking around to understand the chaos that inevitably occurred, exits from SSID Port Authority, right? So all of these things were logged, and it took about 8 minutes, right? 8 minutes from the initial DOF attack into the wireless infrastructure to launch software, to move laterally through the network, right? To find targets, port scans, connect to that device, and then the execution of write commands against that Modbus PLC. 8 minutes in and out, which is fairly concerning because what that really tells us in this particular instance and many other instances are the folks that are not looking for ransomware, right? That'll sit in the network for months, maybe quarters, maybe a year doing forensics. Maybe it's maybe it's a cottage industry where somebody is then selling access into critical infrastructure to anybody on the dark web that's willing to pay for it. So that exploit will live there over time. In this particular instance, this individual, XPS Black, was looking to take down, in this case, critical infrastructure, which was a PLC operating a crane that then dropped 40-foot container into the port, right? So this individual, in and out in 8 minutes. So the question we should be asking ourselves is, A, why are all these things logged and why did it drop, right? But B, do we have what we need inside of our networks to actually be able to respond within 8 minutes? So as we move forward, not only were each of the activities logged within those 8 minutes, but there were also alerts that were triggered. The very first alert that was triggered was the XPS Black device joining SSID Port Authority, right? So there was actually an alert that said, unknown device, new MAC address, device we've never seen before. I want an alert. Bang, one was triggered. An alert was triggered that a device not only attempted to connect to SSID Port Authority, but actually did. And a moment or two later, another alert fired. And that alert was the unauthorized use of software. So there's actually a policy built within the infrastructure that said, I've got a list of unauthorized software, and if it touches my network, I want an alert. And it triggered because XPS Black, in fact, used Nmap. Moment or two later, an alert was triggered for a port scan, right? So a port scan coming from a device that is not Qualys, port scan coming from a device that is not Rapid7, port scan coming from a device that is not Tenable, right? This device, .116, launched a port scan, and rightfully so, an alert was triggered. Also triggered a couple of MITRE attack alerts, MITRE attack for ICS. 886 and 868 alerts were triggered as XPS Black began to move laterally through the network. Right? As XPS Black then started to connect to various devices, in this case, the Crane PLC, right? It was an unauthorized device connecting maybe Purdue level, maybe from from IT, right, into that Purdue level 1 device. Maybe within OT, it's Purdue level 3 to Purdue level 1. An alert was triggered. But still, a couple of moments later, we've got boom, right? The crane hits the floor. So the big question to ask is, why did the crane drop? If I had a half a dozen different logging activities of what XPS Black was doing as it entered the network, as XPS Black began to leverage unauthorized software, as it began to launch unauthorized activities, which is the port scan, the sweeps, the connection to Crane PLC, right? And then the subsequent alerts Why did the container drop? And it's a very easy answer. And the answer was because Armis was invited in to do forensics, and we're invited in to remediate exactly what would occur in this particular instance, which was a simulation. Thankfully, we should all be breathing out that this was a simulation, and it was a simulation. So Missy, if you're familiar with Missy, they hold an event called Hack the Port, and they invited Armis in. And they said, listen, we want an entity to log all the activities that occurred across this particular instance. Now, they didn't tell us what was going to happen, but they said there's going to be an intrusion of sorts, and it's going to be looking to hit critical infrastructure. What we are looking for is someone basically just to do forensics, because we want to open up the dialogue of what just happened, and this was all done live in Tampa last year, what just happened, and then we want to open up discussion on how to best address an adversary that can get in and out in 7 minutes and wreak such havoc as we're about to show. So I said, well, wait a minute. You know, our job, myself and our like vendors in the OT security space, our job is to stop this from happening, right? Let me kill it at the wireless LAN controller. Let me kill it at the firewall. Let me stick it in a quarantine VLAN. No. That would be a very boring simulation, rightfully so. So we agreed that we would sit there and do forensics, and then report back what this adversary did, how they did it, the timing it took for them to move laterally to launch applications, and then we want to actually see that crane drop, or that container drop from the crane. So that's what we did, and that is exactly what you just saw. So we then, there were hundreds of folks that then began conversation about how do we address physical infrastructure, critical infrastructure, right? It doesn't have to necessarily be a port. This could be a pipeline. This could be a utility. This could be critical manufacturing. It could be virtually any piece of critical infrastructure. Let's start a dialogue on what it looks like. What is the art of possible, right? We saw XPS Black get in, get out. We saw them move across multiple layers of infrastructure, right? Level 4 in Purdue, all the way down to the PLC and the device attached to the PLC. So the conversation then evolved to, well, how do I stay left of boom, right? Boom is the container dropping. How do I stay left of that? So folks engaged in conversation around, well, what are the points? What does the kill chain look like, right? So I've got an adversary that came in through my wireless infrastructure. Multiple activities have occurred. They moved laterally, they moved north-south, and they ended up on a PLC with coil rate commands, right? So conversation is like, how do I stay left of boom, right? How do I leverage the existing platform tools that most all organizations have? Most all organizations have wireless infrastructure. Obviously, they've got firewall infrastructures. Some have NACs, plenty of switches, SIMs and SOARs, scanning platforms. Is it possible to, what is the art of what is possible to leverage that existing infrastructure, right? So, when we take a look at what occurred in this particular example, right, there was obviously a wireless LAN infrastructure, right, because that's where XPS Black connected. There's firewalls, there's NACs, SIMs and SOARs, endpoint protection. There are certainly plenty of ways to insert into the existing infrastructure. So then we dug down into that, right? The very first place that XPS Black connected was the wireless infrastructure. And what that really suggests is, right, we need solutions that integrate across any and all types of devices, wired devices, wireless devices. Obviously, vectors of threats come from internal to the organization. They come from outside of the organization. If they come from outside of the organization, they either come from the internet, from afar, or potentially they come from a wireless infrastructure where potentially somebody is local to the facility, which is exactly what happened here in this particular instance. So we've got the wireless LAN controller, right? We've got the firewall where we could insert into to kill TCP connections, right? As long as these systems are working together, right? There is a way to insert probably about a half a dozen different places as those activities are being engaged throughout the infrastructure, right? It's defense in depth, it's layered defenses. It's giving you every possible opportunity that you have, right, to see something that you don't like, even so far as when an application is launched across a network from an unauthorized device or a new device, right? Maybe it's a piece of software that launches that application. There are plenty of places to insert into this kill chain, right, before it even gets to the PLC. Now, I'll suggest, yeah, I mean, we've got OT-centric security products that do an absolutely wonderful job within our OT environments, right? And we're monitoring for activities, right? We're monitoring for unauthorized usage. We're monitoring for activities called against critical infrastructure that is out of the norm, right? Extremely important that we do so. But I guess our argument is, why not expand scope, right, to address that XPS black before it even gets into the OT environment? So that is one of the discussions that came out of this exercise. The other one, lesson 2, words of wisdom from Sun Tzu. If you know the enemy and know yourself, you need not fear the results of 100 battles. If you know neither yourself nor your enemy, you will succumb in every one, right? What this is suggesting, and if you look at NIST 62443, if you look at TSA guidance, Zero Trust, the pillar of all of those security frameworks, is it not discovery, right? Is it not the discovery of every component within the system, right? So that we can understand what our protect surface is? Because if we don't understand what our protect surface is, and there's a gap there, right? It's like protecting our homes with a moat, a fence, security alarms, a dog, but the window's open, right? So it's all about understanding all devices as they communicate, wired or wireless, and introduced into the environment. Now, this is really interesting because you could double back with Gartner, with Forrester, an easy Google search with regards to the absolute explosion of devices within our OT environments, within our building management, building automation systems, right, within our IT infrastructure. All these IoT devices, every time we place a new IoT device or OT device or IT device into our infrastructure, the attack surface expands incredibly, right? Because with that new device comes software, firmware, and applications, and with that, we inherit vulnerabilities, right? So what we have here, and in fact, if I had actually circled all the devices that are unmanageable or devices that we can't put agents on that are showing up across all of our infrastructures, printers, badge readers, card swipes, sensors, motion sensors, temperature sensors, heat sensors, right? All of these devices, they're never going to see a CrowdStrike agent, right? And folks in the OT vertical typically don't like to be scanning these devices because it could tip over a critical process. So unfortunately, what we've just done is we have introduced a device into our enterprise that is unmanageable, or it's residing in the shadows. And now as Industry 4.0 and IT and OT convergence is now bringing many of these devices together. So whether it's gas, water, and electric services that we're bringing into this marine port, right? Whether it's gates, automatic gates, motion sensors, security cameras, all of these devices, unfortunately, are all drastically increasing our attack surface because of the vulnerabilities that come with those devices. So how do we stay left of boom, know ourselves, and know our enemies so we need not fear the results? So a bit about 5 minutes of how Armis chose to address what happened at the port in Tampa during this simulation. What we took away, if you recall, was the fact that we need to leverage all of our infrastructure that's available to us to keep folks out of OT. If they get into OT, let's leverage that infrastructure, right? So that was one of the big conversations. And where that evolved from there is, so in OT, most of the time, we're picking up traffic, we're discovering devices, right? If we go back to my comment earlier about the foundational element of basically all security framework is the discovery of components within systems and all of those systems that incorporate our OT environment. That's expanding, right? That's expanding out of OT, and now it's expanding into building management, building automation, and in fact, IT with the convergence. But for the most part, in OT, we pull span, right? We pull span, and we identify devices by the traffic that's put out on the wire, right? So that's what I call simply asset discovery. Span can be fairly limiting. So we've got, we have all of this infrastructure within our environments today, within our IT environments, within our OT environments, that certainly knows a whole host of information about what these devices are. For instance, that PLC, right? Who's the user, right? Does that user have 80 credentials, right? Is that user even allowed on the network? Is that Mac a device that you even want on the network? If it hasn't registered, right, let's put it in a quarantine VLAN. There are systems today that do those types of things, and this is where we're talking about doing contextual enrichment about what these devices are. And the importance of this is that it enables us to make better decisions, right? It's one thing when, in this case, you had maybe an engineering workstation sending a coil write to a PLC, right? That may be allowed all day within our environments, right? Within our operations, right? These devices modify those PLCs. But if we were to add contextual understanding of, well, that device doesn't have endpoint protection on it. That device also is running Windows 7. That device also has patch 1909. That device also is accepting SMBv1. That device is also crossing a boundary. That device is also hitting malicious IPs and domains, right? It hits a little different when we understand the actual true context of what these devices are above and beyond simply what's put on span. So obviously the next step, if you're looking at zero trust, you're looking at NIST, right? The security framework's very important that we understand the connections that these devices are making. In this Marine port example, we had an external device called XPS Black that hit the wireless infrastructure on the IT side and made his way down into the OT side of the network and then launched commands against that PLC, right? So the second step, zero trust or any real good security framework, is I need to understand the dependencies. I need to understand if this device actually needs to hit that PLC and send coil writes, right? Or send rung edits to the ladder diagram. I need to understand the dependencies, because once I understand the dependencies of the communications, I then can get with my network folks and I can write better policies. I can write better ACLs, right? I can really start to tighten down who is able to access that PLC, what protocols they can use, what applications they can use, when they can do it, right? I got the contextual understanding to really tighten down my policies, right? So that I can disallow devices and actions and people that are unwanted within my OT environment. Obviously, risks, vulnerabilities, and threats, as I mentioned earlier, the absolute explosion of these IoT devices is up and to the right. It's interesting, as we look at the numbers of traditional IT-centric devices and the traditional OT-centric devices, right? The AC drives, the PLCs, the historians, the HMIs, the SCADA servers, the DCS systems. It's fairly flat. There's obviously growth in that part of the business. But when you look at the growth of all of these ancillary devices that support operations, right? The building management, the building automation, right? All the ancillary devices, these new what we might call IoT devices, that's up and to the right. That is seemingly doubling every year. The amount of those devices that are coming onto our network, which then means our attack surface is seemingly even more than doubling every year. So yeah, obviously, when that occurrence happens, we then have a huge increase of attack surface, which leads us now to be chasing vulnerabilities. So, when we double back to the Marine port incident that we showed, XPS Black within 7 minutes gains access into that wireless infrastructure, that SSID, port authority, navigates through, launches applications, calls critical commands against that PLC. Important to understand that there can be, and there ideally should be, multiple places to insert into that kill chain, right? The kill chain should not be and only be within OT, and it doesn't have to be, right? The kill chain, if we've got a converged network, right? If we've got IT connections into OT, if we've got building management and building automation devices, we've got cloud-based infrastructure, and this, I will tell you, is going to extend to 5G, right? When 5G comes around, we are going to see a whole new paradigm of devices that interconnect in and out of OT and into and out of the cloud. Uber important to understand that really the best laid plans of protecting OT is to integrate into any and all platforms that are available to keep any and all adversaries out of OT, right? Whether that's coming from the internet, whether that's coming from somebody sitting in the Starbucks downstairs that can connect or do a deauth on a wireless LAN controller infrastructure, right? Whether that's an infected machine that moves from an at-home work environment into a corporate environment and plugs into an IT switch, they plug into an OT switch, and they introduce something into the environment, right? Super important that we understand what is at our disposal. And those are the two things that came out of MISI, right? Understanding how to leverage the existing infrastructure, right, to offer layers of defense to keep folks out of OT, and then understanding what my true protect surface is, knowing that my attack surface is seemingly doubling every year. So I'll leave you with that. I'd like to open it up to any potential questions, whether it be on this particular Hack the Port event and the triaging and forensics that were pulled from it, or from IT/OT convergence, security frameworks, or of Armis in general. Yes. Yeah, so that's a great question. And when I was told that, listen, Armis is just to sit there and do forensics, right? My first reaction was, well, wait a minute, what's your infrastructure look like? Tell me about your wireless LAN controller, Cisco, right? Tell me about your switching platform, right? It was Cisco. Tell me about your endpoint protection that you're running. Tell me about, the different infrastructure that you have available. What's your SIM, right? What's your SOAR? What can we trigger? What can I ingest into Armis? Do you have scanning platforms? And their answers were, we've got Cisco firewalls, we've got Cisco wireless LAN controller infrastructure. We've got no endpoint protection, right? So they had no CrowdStrike, no Carbon Black, no Sentinel-1 on their devices, no McAfee, no Windows, Defender type of endpoint agents. So what we would have done is we would have built a policy right at that wireless LAN controller that says if in a critical infrastructure, obviously you got a port, it's fairly locked down, right? Which most all OT environments are fairly locked down. They said we would have registered all of our Macs and given them to you. When somebody new comes on-prem, we'd have them register the Mac of their machine, and we would go put it into a whitelist so that if any device attempted to connect and pull an IP address from Active Directory or from any, any of the services, Infoblocks or whatever services that they run, the NAC platform that they've got, we would have written a policy that said stick it in a quarantine VLAN or just deny it altogether. So that's what I had suggested to keep the adversary off of the premises to begin with. That's when they came back and said, well, it'd be a pretty boring simulation if we never got to the PLC. Does that help to answer your question? And then there was some firewalling. They had, I think it was Cisco ICE. So that would have been another place where we would have inserted. And then, I'm sorry? Yeah, and then, you have the ability to, as these devices put data out on the wire, and in this particular instance, it launched Nmap, right? And it launched the activity of a port scan. So at that point, right, that can trigger an activity. So I'll just speak on behalf of Armis for a moment. We orchestrate those activities within the existing infrastructure. So we would have orchestrated, hey, stick that wireless request into a quarantine VLAN, or just don't let it on the network, and then it wouldn't have been let on the network by the Cisco wireless infrastructure. It would have been the same for the firewall infrastructure and the switching infrastructure. We would have orchestrated that device either killing a TCP connection, denying acceptance to the network, or placing in a quarantine VLAN. It was. It was. It was. Again, and it was a simulation. So, you know, it was a fairly open network. And unfortunately, there are several open networks around us, manufacturing. You know, it's almost seemingly the status quo with regards to how these networks were built through mergers and acquisitions, how they're really not tightened down as much as maybe utility might be, wastewater might be, but this was a pretty open network. Yeah.
I was going to say, was this a flat network like OT and non-OTS? It's all on the same network. I had to step out of the road.
So the OT side was flat.
Yeah.
Yes, but it had to traverse through infrastructure to get there. So it came in on the wireless LAN controller side, and then found its way into OT, which is not uncommon because you can take a Dell machine, an HP machine, maybe a server that's got two NICs on it. It's got an RJ45 NIC that's plugged into the OT switch, and then it also has a wireless NIC on it, right? And maybe that user's told not to use the wireless NIC, right? This machine is not there, the wireless NIC is not there to be used, or maybe they're not told anything, and all of a sudden, and we see this all the time, the operator of that machine is hitting PLCs, hitting critical processes on the RJ45 port that's plugged into the switch, but then lunch comes around or they got a break and they're on Amazon ordering a refrigerator, right? They're on cars.com. You would be amazed, and they're hitting it via their wireless NIC, right? They're connecting to maybe their MiFi, or maybe they're connecting to Starbucks downstairs. Maybe they're connecting to the guest network. Maybe they're connecting into IT. And what they're effectively doing is they're creating a bridge, right? They're creating a bridge between an exterior network and OT via their machine. Any other questions? Well, thanks. I know that we had, we're about right on time. So if anybody has any questions, absolutely feel free to ask them now or to approach afterwards. We can certainly talk about this particular infrastructure attack. Again, the two main takeaways were leverage the existing infrastructure that you have, defense in layers, keep them out of OT, address them in IT, as that's where most of the threats come from. And then obviously what triggers that is fully understanding the device catalog of any device, wired or wireless, that communicates within the infrastructure, because any device that is attached to the enterprise is potentially a vector into OT. So thank you very much.